Okay, so let's go ahead and get started. Hello and welcome to the Rockford Systems Debunking the Top 3, which is now the Top 4 Machine Safeguarding Myths webinar. As we were creating this webinar, we actually decided to throw in a bonus myth, so today you're getting 4. We're ready to begin. My name is Carrie Halley, and I'm the moderator for today's session. Your presenters are myself, along with Mr. Roger Harrison, Director of Training for Rockford Systems, who has over 30 years of machine safeguarding experience. You have arrived in mute so that the presenter can speak clearly without background noise. We will have time at the end of the presentation for questions and answers, so please do type your question in the chat box at any time during the webinar. Also, please stay until the end of the webinar so that you can cast your vote in our poll to help us improve the quality of the webinar for the future. Okay, so before Roger gets started, I just wanted to take a brief moment to introduce Rockford Systems to you. We are located in Rockford, Illinois, just outside of Chicago, offering quality machine safety solutions since 1971. As a trusted advisor to industry, we educate organizations on how to interpret and apply the complex OSHA regulations and ANSI standards for machine guarding. In addition, Rockford offers a full suite of machine safety solutions, ranging from on-site risk assessments and machine surveys, through product installation, training, and support, and ultimately culminating with ongoing compliance validation. Please visit our website, rockfordsystems.com, to learn more about our full range of machine safety lifecycle management solutions, join our newsletter mailing list, and please follow us on social media. So our webinar topic, Debunking the Top 4 Machine Safeguarding Myths, was chosen as a response to the fact that annual injuries resulting from a lack of proper machine guarding are not declining at a significant rate. As reported in Safety and Health, a lack of machine guarding is consistently on OSHA's Top 10 Most Cited Violations report. The actual price tag for an injury is much higher than simply the OSHA citation, because indirect costs must be also taken into account, such as damaged facilities or equipment, medical expenses, lawsuits, lost productivity, replacement personnel, etc. Worst of all, these accidents can cause very severe, potentially life-changing injuries or even death to employees. It's estimated that workers who operate and maintain machinery suffer approximately 18,000 amputations, lacerations, crushing injuries, abrasions, and most profoundly, more than 800 deaths per year. In 2016 alone, 88% of the total number of OSHA machine guarding violations were classified as serious, meaning one in which there is a substantial probability that death or serious physical harm could result, and the employer knew or should have known of the hazard. So really, after a decade of dismal improvement, we need to make machine safety a higher priority. Having been on thousands of machine surveys, we estimate that an alarming 50% or more of metal fabricating machinery in the United States do not comply with the critical safety requirements for guarding outlined by OSHA and ANSI. So without further ado, I'm going to go ahead and turn this over to Roger Harrison, who will take you through the top 4 machine safeguarding myths. Roger.
Thank you. Good morning. My name is Roger Harrison. I'm the Director of Training for Rockford Systems. So for the next 40 minutes or so, we're going to go look at the common myths on the subject of machine safeguarding with an emphasis on the regulatory side of things. Number 1, new myths. New machines are safe or good to go because their manufacturers sold them as fully compliant with OSHA regulations and other safety standards. Myth 2, older machines are exempt from OSHA's machine safety regulations because they're grandfathered in. 3, automation cells containing industrial robots are always properly safeguarded by the robot supplier. And 4, OSHA regulations are only guidelines, not the law. So, Myth number one, new machines are safe because their manufacturers built them to meet up-to-date safety standards and regulations. Well, it depends on the country where the machines were built and the safety standards the machine manufacturer uses as a guideline for designing them, building them, installing them, and the control systems along with the electrical components. Keeping in mind NFPA 79, 2015, which is the electrical standard for industrial machinery, which does not get as much press as NFPA 70E that deals with the arc flash issues. Also depends on the machine's safeguarding expertise on the company supplying the machine, the OEM. Some are more comfortable with that than others. Two, the OEM's reluctance to add safeguard to the machine project's cost, because it does cost, whatever, the way you're going to safeguard it. And three, the OEM's concern about liability of providing safeguarding, whether they want to do that or not. I heard one press manufacturer a few years ago say, well, we provide presses, and essentially a press is just a big powered hammer. It's a general purpose machine. A lot of different things you can do with the same machine depending on the tooling and the parts that you're making. So they hesitate to provide the safeguarding for that reason. Now that's changing somewhat because Asian and European manufacturers of machines have for some time now provided their machines fully safeguarded. So the American manufacturers look at theirs and say, well, we have to offer safeguarding at least as an option, if not a standard feature. So the attitudes are changing. It's important when you bid spec new machines to specify the safety-related parts of machine controls, abbreviated as SRP/CS, for which the equipment has to comply. Now, one of those references would be ANSI B1119 2010. So don't hesitate to spell out clause or paragraph numbers from these standards as opposed to just saying, well, this machine has to meet all federal, state, local safety guidelines, blah, blah, blah. You really need to spell them out, and I think that's what a class like this will do to help you in doing that. Remember that safety standards from European Machine Guarding Standards, or EU standards, along with Canadian Association Standards, CSA, often offer higher levels of protection than U.S. ANSI standards do. So every time they update U.S. ANSI standards, they take more and more from the European machinery guarding standards to hopefully harmonize our standards to eventually meet theirs. Here's an example of a new drill press that we needed to add some things to make it compliant with ANSI B11H on drills and mills, along with that electrical standard for industrial machinery I mentioned before. Now you can see here at the top that we added a magnetic motor starter to give us dropout protection, also known as anti-restart. Well, what's that mean? If you lose power while the machine is running, 15, 20 minutes later the power comes back, you don't want any surprise restarts until you go back to the main motor start button. That's anti-restart. How do you know if your motor starter has that feature? Well, usually a spring-loaded start button indicates that, as opposed to a mechanical click that they had on older manual motor starters. We've also added a red emergency stop button. Notice it's a red button with a yellow background and a manual latch feature, so when you push it down, it stays down. You got to give it a quarter turn clockwise to reset it before you can go back to the regular machine controls, which in this case would be the on button, to restart it. Second thing we've added to this is a shield to help control chips and coolant. So the shield actually supplements your personal protective equipment in directing the chips where you want them to go. This particular shield is electrically interlocked. You can see the interlock switch over on the left side here, so when you swing it out of the way, it either prevents or stops the motion of the machine. Thirdly, we've added a lockout plug at the bottom. So when you are working on this machine, you have a place to lock the plug, which is considered adequate if you have a cord and plug connected machine. So that's the updates we've added to make this comply with the ANSI B11.8 and the electrical standard for industrial machines. We've done similar things here with this mill-drill combination as far as electrical requirements. And you'll notice the shield, this rounded curvature shield here, gives you a wider field of view, better visibility than smaller shields would do. It's also electrically interlocked. We've done some of the same electrical updates we discussed in the previous slide. You can see them over here. And the same thing goes with the lockout plug. Chip coolant hazards are addressed in OSHA's 1910-212, where they talk about flying chips and sparks as one of the recognized hazards you need to deal with. Now, if you look at this lathe, you have a chip coolant shield positioned to help control where the chips are going so they're not flying out and hitting the operator in their upper body or collecting on the floor where they might create a slip-trip hazard. As far as this milling machine, we've got an angular universal swing-away shield that you can position to do the same thing. And then down here on the drill press, something very similar. So again, the shields pick up where the PPE leaves off. Here's an engine lathe with two different shields. The one on the left is a chuck shield to prevent you from getting entangled in the rotating work holder, because remember, these machines have a lot of torque. So if you get wound up in these, they can create some pretty gruesome injuries. So even though that shield is not considered a guard, as we'll talk about later, it's really the most common thing you see on an engine lathe to prevent inadvertently coming in contact with that rotating chuck. And it happens to be electrically interlocked, although that's not a requirement here in the U.S. to have an interlocked shield like it is an interlocked guard we'll talk about later. Over on the right-hand side, we've got a chip coolant shield, also with a built-in interlock, which has two different axes of movement, as you can see by the yellow arrows. So these are actually European designs of shields, because they do include those interlock switches. Here we're looking at an engine lathe that's been updated with telescopic stainless steel sleeves to cover the horizontal rotating components like lead screw, feed rod, traverse rod, camshaft, etc. These segments all collapse into the largest segment down on the right-hand side here, so you do lose a little bit of carriage travel. On this end, understanding there's a set of these on the other side that you can't see from this angle. So if that's a 4-inch length on that largest diameter, you're losing 4 inches on both directions. I suppose the reason that some companies don't use these are that fact that you lose some carriage travel and the fact that you have to partially disassemble the machine in order to, clean out or whatever these shields. So there are some maintenance issues with these, but they are definitely considered. The sleeves are definitely considered the best safety practice to prevent entanglement with those horizontal rotating components. Let's look at a couple of stamping presses that we updated for the FabTech show in Las Vegas a couple of months ago. On the left, we've got a servo drive press, which is the newest technology for presses. And on the right, we have a straight side mechanical power press, which a lot of people refer to as a flywheel press. Someplace there up on top, there's a rotating flywheel. Let's see, for the gap frame press on the left, we've got two sets of light curtains, one vertical and one on an angle to keep somebody from standing in between the vertical light curtain and the machine. Then we've got a set of two-hand controls, which could be considered a safeguarding device if it meets the rules for two-hand controls. And you're always better off with a two-hand control than a foot switch, because with a foot switch you don't know where the operator's hands are. Whereas with a two-hand control you do. But there is a list of requirements to use a two-hand control as a safeguarding device. Then we've got an adjustable side guard, which allows for different size scrap, presumably, to drop off the left side. And at the bottom, we've got an electrically interlocked safety block. And by the way, you may want to see our blog post on safety blocks on our website under Resources, and then scroll down the machine Safety Blocks. On the right side, we have 3 sets of light curtains we can see from this angle, and I think a 4th one little angular light curtain is hiding underneath the other side. So that's fairly common to use light curtains on a press this size. And again, we need an electrically interlocked safety block. Anytime you are adjusting or repairing dies while they're in the press, you need a safety block to prop up the dead weight of the slide and the upper die if the brake or counterbalance should fail. That's the reason to use them. However, safety blocks will not hold back the driving force of the press. So you must have an electrical interlock circuit on these. Well, who says that? Well, OSHA says you need the safety block, but ANSI says that you need the interlock circuit, so that you have to pull the plug to remove the safety block from its holder, wait for the flywheel to coast down before you place it in the point of operation. Now, while we have this slide up comparing servo drive presses to straight side mechanical power presses, it seems for now that OSHA is putting servo drive presses in the category of a mechanical power press, meaning they fall under 1910-217, meaning they have similar requirements to a mechanical press. Well, if you look at the definition of a servo press, they really don't have the same drive system as a mechanical power press. If you were to Google one of the press manufacturers for servo presses, like, for instance, Komatsu, Komatsu, or AIDA, that's AIDA, you get a full explanation of how those drive systems work. Let's take a look at a hydraulic press brake. This is a down-acting machine, meaning the top half moves up and down, which is the most common design of the 42 manufacturers or so of press brakes that are out there. Now, just one thing at a time, we've got an active optical protective device, also known as a laser device. It was invented around 2001. And if you Google that, you'll find 4 or 5 manufacturers of that type of device. The nice thing about a laser device is that the operator can handhold the part up close to the die and still be protected, which is a very difficult thing to do with a light curtain because of blanking issues on the light curtain. Now, we do have a vertical light curtain on this machine in addition to the AOPD laser device. The reason for that is the laser device is not capable of handling all different types of dies used in the machine, like a compound die is something you can't deal with, as an example. Therefore, the light curtain acts as a backup safeguarding means to the laser device. Is it required to have both devices? No, it's just there as a backup. Over on the right side, you can see a back-to-back two-hand control, which is something you might be able to use not only for cycle actuation, but as a safeguarding device if you're able to fixture the piece part in place, so the operator doesn't have to hand hold the part during the bend, which is normally what goes on. Then you've got hinged corner guards, which you can swing out of the way so you can slide your tooling in from the end, which is what's normally required to do that. What you cannot see from this angle is a sliding interlocked vertical guard on the back side, which prevents people from getting in the back of the machine without opening up the interlock on the guard. So we have several different means of safeguarding on this hydraulic press brake. Keep in mind that that laser device only applies to hydraulic press brakes, not mechanical. And there are still some mechanical press brakes out there which you can put certain safeguarding devices on, but a laser device is not one of them. Now that we completed myth number 1, let's move on to myth number 2, which is that older machines are somehow grandfathered in since they were manufactured before the safety standards and regulations existed. Well, it's logical, but it's not true. All machines, regardless of age, must at very least meet minimum OSHA regulations, which were, what's the word they use, promulgated back in 1970, and unfortunately they've had very few changes since then. So if you want up to date, you're going to have to go beyond OSHA. And going beyond usually requires looking at the 24 different ANSI B11 safety standards for metalworking machines, that have been around since the 1920s. Now, the thing about ANSI standards is they have to be updated. Every 5 years, the writing committees have to either rewrite the standard or reaffirm the standard, which is to accept that standard as is, no changes, if there hasn't been enough change in the technology or they can't get a writing committee together. Or third option is to drop the standard or combine it with another similar standard, like they did about 20 years ago. With the coil slitting standard, B1114, they combined that with the cut-to-length line standard, B1118. Now they call it a coil processing ANSI standard, B1118. So there's activity every 5 years, which there is not with OSHA regulations. So if you're exceeding minimum OSHA regulations to achieve the best safety practice, as is the case by using ANSI standards, it also helps your company meet due diligence in case there's ever litigation after a serious machine accident. So some examples of older machines. The top left here, we've got an old mechanical power press, which at least from this angle does not appear to have any safeguarding, no guard device that we can see. The lower left, you've got a shear with a point of operation guard here that's tied up out of the way. I'm not sure if that's for maintenance or setup or if they're actually keeping the guard up here for production. In the lower right, you see an older engine lathe that has rotating components. I'm talking about a gear like this one or rotating belts and pulleys that need to be covered up to at least a 7-foot level from the floor to meet OSHA, or an 8-foot level from the floor to meet the best practice in the ANSI standard. Here we've got an old Bridgeport J-head machine, which they made up until 1957, and believe it or not, there's still a lot of these out there that have an opening on the top of the head to change the speed, because this was before variable speed drives. So somebody had to access the belts and the pulleys to change the speeds. Well, that's a rotating component hazard under OSHA's 1910-219 and needs a cover. And that cover needs to be held closed with a fastener that requires a tool, as opposed to just the spring clip that we've got here. So as you can see, this is custom sized for a Bridgeport. It has holes for heat dissipation, and there's a similar cover on the other side. But that opening does need to be covered. Now let's take a look at the ANSI B11 safety standards, which started out as 24 standards, and now by adding the B11.0, it's 25 standards. Now you want to start out with this first one, safety of machinery and risk assessment, because most everything for the last almost 20 years now has been based on risk assessment. Let's see, there's 2 of them in red. B11.1 mechanical power presses and the B11.9 for grinders, because those 2 have a corresponding OSHA regulation we're going to look at later. So you want to pay special attention if you have mechanical power presses or grinders. The rest of these machines on this page fall under OSHA's general requirements, 1910-212, which says the employer's got to provide safeguarding for people exposed to hazards. And for that, you oftentimes have to refer to ANSI standards because OSHA doesn't say too much about the details. Here's the second half of that list, and you notice the bottom item here, American National Standards Institute, Robotic Industries Association, R15.06 on robot safeguarding. There's a 99 version of that, which is still current, and the updated 2012 version. We're going to discuss more about that later, and I thought I ought to put them in here because later on we're going to see some examples. Now, all 24 of these standards refer back to ANSI B1119 because that is the safeguarding methods standard. It talks about guards, devices, distance, location, and opening. We're coming back to those 5 methods. There's also B11 technical reports that are published and available from the same sources you get the ANSI standards from, which, by the way, if you Google this, you could look at ansistore.org or techstreet.com or global.ihs.org or roboticsonline.com for the robot standards. Most of these are around $85, although the robot standard, at least that latest one from 2012, is $325, just to give you an idea. Now, some of these sources offer these as paper copies, others offer PDF files, and some offer both, just to give you an idea. How about a bench grinder? That's one of the machines that has a machine-specific regulation, meaning a list of do's and don'ts. It's considered a vertical regulation by OSHA, which they pay more attention to. What are some of the things you need to do for a bench or pedestal grinder? Well, first you want to ring test the wheel before you mount it to the machine. Ring test the wheel, and that needs to be documented, by the way, with the training requirements on that, which means you suspend the grinding wheel by the center hole, tap it around its outside diameter with a non-metallic object like a piece of hardwood to make sure the wheel will ring like a bell tone when you tap it, as opposed to a thud or cracked plate sound you'll get if you've got a cracked wheel, and you never want to mount a cracked wheel. So ring testing is required by OSHA. They also suggest that you stand aside from that machine for at least a full minute, because if the grinding wheel were to shatter, it usually happens within the first minute. So that should be part of your safety training with grinders. The red curved direction arrow is usually for larger diameter grinding wheels, like maybe 18 inches or more in diameter, because those are usually used on larger machines that have three-phase power. If you should, during maintenance, disconnect the power, and then when the power is reconnected, accidentally reverse the phases in the motor, of course the grinding wheel would be running backwards, which is very dangerous. So you need a direction arrow for the larger grinders and the larger wheels. Now the tongue guard, also known as the spark arrestor, can have no more than a 1/4 inch opening where that arrow shows you. You need to cover the wheel with something that also encloses the spindle end and nut. Now what are you missing on this grinding wheel cover? The bolts. You got to have all the fasteners to maintain the strength and integrity of the grinder wheel cover. So what's the big one with grinders? Well, that would be an 1/8 inch maximum opening between the work rest and the wheel, because the wheel wears down as you grind parts. That is the #1 machine safeguarding OSHA violation, has been for 46 years when OSHA first came out. So there's the paragraph within 1910.215 OSHA that tells you when you need to use that. And you'll notice there's also a couple of ANSI standards on abrasive wheels and grinders that are very current, and you may want to also access. By the way, as far as the wheel covers, you cannot cut away a wheel cover to any more than a 90-degree maximum opening. A 65-degree opening between the horizontal plane and the top is also in OSHA, and it's under paragraph B3 if you need to look it up. So 90 maximum, 65 for the area that you're actually using. So there's a grinder check tool to check the 1/8 inch opening between the work rest and the wheel, and the 1/4 inch opening between the tongue guard and the wheel. I don't think I mentioned on the previous slide that the reason for not cutting open the wheel cover is if you do, I saw one company that opened up the wheel cover to like 180 degrees, it gives you a wider spread of fragments should the grinding wheel shatter. And when you say shatter, that usually means explode. So that's why those are in OSHA. So now that we're done with myth 2, let's move on to myth 3, where it says automation cells containing industrial robots are always properly safeguarded by the robot supplier. And sometimes that is true, but not always. Some of the manufacturers of these machines are not comfortable with the safeguarding, as we mentioned before, so it's left to an aftermarket manufacturer to provide the safeguarding. And by the way, you may want to check out our blog post for robots in early January. It's on our website. What do we have here for safeguarding on this robot cell? Well, perimeter guards with interlocks should be the basis for safeguarding any larger robot, like a 6-axis robot. They typically need a perimeter guard or fence. Second thing you can see here is two light curtains, one here and one over here, vertically mounted light curtains. And the third thing, well, I don't think we have it here, but we do in the next picture, would be an area laser scanner. So between the perimeter guard, the light curtains, and area laser scanners, those are most common with larger robots. Now, we need to consider the European safety-related parts of control systems when we get into this automation system. For the prevention of faults, there's two things. Category B, which are safety-related parts that will withstand the environment, and Category 1, which are well-tried safety components. So these are pretty basic. Most of our concern would be for the detection of faults, like Category 2, components that are monitored before you start up and periodically thereafter, like, for instance, pressure-sensitive mats or drop probe devices, also known as ring drops or halo devices for spot welders and riveters. Radio frequency antenna would be another one for Category 2. That's fairly low category of protection. Your better guard interlock switches would be a Category 3 that are dual monitored, so a single fault doesn't lead to the loss of the safety function. And finally, Category 4 would be your better light curtains out there that are dual monitored with all foreseeable faults detected. So light curtains are not all the same. If you Google light curtains, you want to make sure you're dealing with a Category 4 light curtain. If you Google guard interlock switches, you want to make sure you're dealing with at least a Category 3 switch. And again, these come from European regulations, but a lot of this has already been incorporated into updated ANSI standards over here. Another example of a robot automation cell. Well, let's see. We've got a perimeter guard like this one. Down at the bottom, very bottom, 12-inch sweep and a 60-inch height comes from the American National Standard Robotic Industries Association, R1506, 1999. That's not the updated standard, because the updated 2012 standard does not deal with the fence height issue. Where do we go to get best practice in? Well, it'd be the Canadian standard, CSA 2003, which has had the new fence height in there for, a long time now, since 2003, which has a 6-inch height at the bottom, that's from the sweep to the floor, and a 72-inch height. That's best practice, even though we cannot take it from a U.S. standard, at least not right now. So, vertical light curtain, we've got that for the operator's turntable, as you can see. An area laser scanner, which you can program, in this case, for the L shape that this is protecting. On a laptop computer out on the shop floor, you can program it, and you can reprogram it if your parameters change, which is the nice thing about that. I've got 3 red emergency stop buttons on the left, the center, and the right. And I've got an interlocked guard door, interlock switch on the door, along with an output signal switching device, which means if this is running along continuous like it's supposed to, because it's automated, and it all of a sudden stops, you need to know what to check. What tripped? Why did the thing stop? That completes myth 3. Let's move on to myth number 4, where it says OSHA regulations are only safety guidelines for manufacturers, but not really the law. Well, no, that's not true. Never has been. The Williams-Steiger Act, which 2 congressmen from the state of Wisconsin back in 1970 introduced this legislation which established OSHA. General Duty Clause 5A1, that's the employer's responsibility for a safe and healthful workplace. And there's some other things we can take a look at in there as well. Now, all the states, all 50 states, started out as OSHA federal supervision, federal OSHA states. Through the years, I think about 23 states have petitioned to become a state-approved plan. So there's state OSHA plans and there's federal OSHA plans, but they pretty much go under the same rules. So employers are required to follow the OSHA regulations. When they talk about COSHAs, that's compliance and safety and health officers here. We'll issue citations if you don't follow the stuff in this CFR. 212 says the Employers got to protect the operator and anybody else in the machine area from exposure to recognized hazards using guards, devices, or methods, or some combination of those. Keep in mind, OSHA is well aware of the fact that their machine guarding regulations have changed very little since the 70s. Therefore, if you want to stay current, got to go with ANSI standards, because OSHA regulations just have so little that's up to date. So if you're cited, the best place to go for advice is that B11 series of ANSI standards we've been talking about. Now, B1119 is the Safeguarding Methods Standard, also known as the Safeguarding Criteria Standard. I think when they update it next year, it's going to have yet a different name that includes risk assessment. But this is where you find the 5 basic methods of safeguarding. Guards, which could be either perimeter or point of operation guards. Devices, which could be light curtains, laser scanners, and so on. Safeguarding by distance usually involves a large, bulky part that the operator has to hand hold that theoretically keeps him far enough away from the hazard to prevent him from getting hurt. Safeguarding by location would be the operator's physical location in regards to the hazard area. And safe opening is currently a 1/4 inch or less. If you've got a machine that doesn't open up more than a 1/4 inch, that may be enough safeguarding because a small finger can't get in that opening. Well, it may or may not be true, because as I understand, they're changing that next year and getting rid of the 1/4 inch opening and just saying no body part can fit in that opening and not actually putting a dimension on it. In the early years, the ANSI B11 standards had their own safeguarding section, each one of them, which means you had to buy all the copies of the 24 different standards for the machines you wanted to look up safeguarding on. Now, in the B1119-2010, the safeguarding sections for each of the standards were consolidated into this one umbrella standard as B1119 for the user's convenience and to prevent them from having to buy all of the standards. So OSHA's 5A1, what's it say in the general duty clause? Employers got to furnish a place of employment free from recognized hazards likely to cause death or serious physical harm to operators. Employees do have responsibilities here to follow the rules and regulations that apply to their own actions and conduct. You know, I have heard of a couple instances where an employee was trained not to do something that was well documented, but continued to do it, even though it was a very dangerous thing to do. Not only did that employee continue to do that himself, but trained another operator to do that same dangerous thing, and that second operator was seriously injured. So, as I understand, OSHA cited the first employee because they considered that egregious or serious enough to justify paragraph 5B, employee citations. OSHA's 212 requirements under A1 says the employer's got to protect the operator and other employees in the machine area from exposure to hazards, like point of operation hazards, where the tooling comes together to make the part. That's the point of operation, which every machine has at least one. Ingoing net points, rotating parts, flying chips and sparks. So you've seen some examples that are listed over here on the side in red of the safeguarding methods that OSHA lists. But that's not a complete list by any means. That's just some examples from 212A1. So general requirements, 212A32 says the guarding device should be in conformity with any appropriate standards. Well, what could be more appropriate than the ANSI B11 standards from which these regulations came? There was a window of opportunity for OSHA back in the early 70s when they could take existing ANSI standards and adopt them into their own regulations and rebadge them as an OSHA regulation. But that was only for a few years. That method is no longer available to them, so now to promulgate a new, especially machine-specific or vertical OSHA regulation, it takes an act of Congress. So, Subpart O, machinery and machine safeguarding. The 6 machines inside the box are considered vertical or machine-specific regulations. What's that mean? Got a list of do's and don'ts for each of them in OSHA. So OSHA tends to lean towards these machine-specific regulations for citations. Look on the far left side here. You see the 3 arrows? Those are the three that seem to collect the most OSHA citations. 1910-213 for woodworking, 1910-215 for abrasive wheels or grinders, and 1910-217 for mechanical power presses, simply because there are a lot of those machines, I would expect. The machines outside the box would be the 211 definitions. I think I mentioned that before. The general requirements, which we have defined, and 1910-219 down here at the bottom, talking about mechanical power transmission apparatus, so that rotating components like flywheels, gears, sprockets, chains need to be covered up to at least a 7-foot level from the floor to meet OSHA, or if you want to go best practice in the ANSI, an 8-foot level from the floor. So as a summary, myth one, new machines are safe because the manufacturers designed them that way? Not necessarily. You need to have a risk assessment and a machine survey to identify potential problems, whether they're OSHA things or ANSI issues. Older machines are grandfathered in? No. You've seen there are no grandfather clauses, so that takes care of myth number two. Number three, automation cells containing industrial robots are not always properly safeguarded. We know that. Some are and some are not, but you got to make that very clear exactly what standards regulations that robot cell meets before you purchase it if you're buying the safeguarding from the OEM of the equipment. Myth number four, OSHA regulations are only safety guidelines, not the law. Well, as we've said, they are. They've always been the law. It just depends on whether or not you have a federal OSHA state or if you have a state-approved plan. Now, in 2 months, let's see, we're in April, we're going to have another webinar on comparing risk assessment to machine surveys. Now, with risk assessment, which is based on that risk assessment ANSI B11.0, that produces a hazard score and a risk level for each machine and offers suggestion to lower the hazard level, along with detailed documentation to outline the results. Whereas a machine survey based on what we just talked about, ANSI standards, OSHA regulations, each machine is audited for compliance to OSHA regs or ANSI standards. And there are still some companies out there that have not brought their machines up to minimum OSHA. I'd say in most cases they have, so they do these machine surveys as an ANSI standard machine survey, in other words, up to best practice. Then you get a customized proposal with specific products and services to bring this up to best practice. So that's what we're going to do in early April for a webinar. If you're not familiar, this is the risk scoring system that's used for what we do out there on a risk assessment. If you have questions, please type them into your chat box. You may be able to take them at this time, or you can email them to our VP Sales, matt.brenner@rockfordsystems.com. So again, April 6th, we've got a Machine Compliance 101 seminar, meaning I gave you the wrong information there. I'm sorry. This is something we did in December, and we're going to repeat April 6th. In June, there we go, June 6th, we've got a webinar on risk assessment versus machine survey, which one's right for you. So I'm sorry, I had the dates confused there. Also notice, if you want to register for webinars and seminars on the web, look under rockfordsystems.com under education. Look under education. You'll see how to register for these. On the right side, you see the list of remaining seminars that we have for 2017. We'll hold 11 seminars per year, all except December. Got a 2.5-day class, all except December. It's 2 full days, and then just a few hours on the third morning to do our testing, and then we send you on your way.
Okay. Well, that pretty much wraps up Roger's presentation. And what I'd like to do now is go ahead and check on our questions. The first question is, where can I get a copy of the presentation? You will note that I did attach a PDF document to this webinar. If you look in your control panel, you should be able to download the presentation directly from this webinar. Alternatively, we have recorded this webinar, and that will be available for viewing also on our website under education and webinars. Probably check back tomorrow or so to get that. Okay, let's see. I have a question from Marcos. Are pedestal grinders required to have anti-restart prevention in the U.S.?
According to the best safety practices in the Electrical Standard for Industrial Machinery, NFPA 79, yes. If you're asking what is OSHA going to get you on if you don't have anti-restart or dropout protection, 2 machines they'll get you on, for sure. Mechanical power presses, all sizes, all types, and woodworking machines being used to cut wood. Those are in their CFR as an absolute must-have. So we're getting the same suggestion for other machines from NFPA 79.
Okay. We have a question from Jimmy. Can you be cited for not meeting ANSI or only if you're not OSHA compliant?
There's no clear answer to that because some OSHA compliance officers will use ANSI B11 standards only because their 1910-212 is so vague. Are ANSI B11 standards incorporated by reference under OSHA's 1910.6? And the answer to that is no. But, again, it's the only place they have to go to get details on safeguarding many, many categories of machines.
Okay, thanks, Roger. We have a question from Mike. Is 24 ANSI B11 quoted by OSHA as a consensus standard?
Say that again, please. I didn't understand.
Sure. Is 24 ANSI B11 quoted by OSHA as a consensus standard?
No, it's quoted by the ANSI Writing Committee. They are consensus standards, yes, because it's a consensus group that writes them. I don't quite understand that question. You may want to email Matt.Brenner on that to ask his opinion, but they're defined as a consensus standard, yes.
Okay. Gosh, we have a lot of questions. Okay, here's a question from John. What are the requirements and proposed aftermarket solutions for the exposed shaft and threaded end of pedestal buffers? For lathe lead screw covers, are there any new solutions which do not reduce the range available?
Answer your second question first. For lathes, no, I don't think there's any updates on that, and you're going to lose some range on the carriage of that machine. The first one, give me the first part of that question again, Karen.
Yeah, the first part was, what are the requirements and proposed aftermarket solutions for the exposed shaft and threaded end of pedestal buffers?
Okay, well, for the exposed shaft, I don't know if there's anything particular, but I have seen companies who have taken the wheel off, installed an oversized diameter piece of PVC pipe with a mounting bracket, put the wheel back on so they're not exposed to the shaft. As far as the end nut, there are plastic caps you can get to snap on those to minimize the chance of somebody's hair clothing becoming entangled in the hex nut. I hope that answers your question.
Okay, thanks, Roger. We have another question from Jody. Do you have a list of consultants around the U.S. that will perform risk assessments or machine surveys? I can go ahead and answer that.
Please do.
Jody, we do have many folks available to do that, both Rockford Systems employees and some independents. I would recommend either emailing us or calling us, and we can get you hooked up with somebody to come out to your site. Got a lot of questions about, again, the slides being downloaded. Somebody is saying that the PDF is, appears to be corrupt. So I apologize if that's the case. What we'll do is we will go ahead and email out to all of you a copy of the PDF slides. And again, feel free to check back to our website maybe tomorrow if you'd like to see this recording and maybe go through it again, because I know that a lot of information was presented. Use the slides in combination with the audio. Let me just check. Okay. Let's see, one more question here from Adrian. How are the guarding requirements impacted if there is a soft wheel, wire, or other wheel types on bench grinders?
Very good question. Soft wheels, wire brushes, by soft wheels I mean like Scotch-Brite, for instance, wire brushes, sanders, buffing, those are not included under OSHA's 1910.215, and to my knowledge anyway, at least in U.S. standards, do not have an ANSI standard of their own to cover them.
Okay. And then Adrian did just add one more comment, for example, removing guards for polishing wheels.
There is. Could you hand me that book, please? There is something in OSHA about that I don't think I mentioned. Let me check it here. Where you can remove the work rest of a grinding wheel to grind large parts as long as you put it back on for small parts, and you also have side guards that are required there. And that comes under an OSHA instruction standard, STD 1-12.8 from October 30th, 1978, which addresses the conditional removal of the wheel cover. I was thinking that meant work rest, but that's what it's saying here, the wheel cover. So you can look that up to get the details and make sure that's right. Possibly temporary removing the work rest for larger parts. Well, there's a conflict here. I'm talking about removing the wheel cover or removing the work rest. I think that should be clarified, and perhaps we can include that with those of you who have requested the the PDF file from the presentation that's not corrupted, and look that up, because believe it or not, as old as that is, STD 1-12.8, October 30th, 1978, under OSHA.gov, that's still in effect. It hasn't been rescinded, but whether it talks about conditional removal of the wheel cover or the work rest, I'm thinking it's work rest and not wheel cover, because I don't know of anything that allows you to remove the wheel cover itself, only the work rest. Did you all get that?
Okay, thanks, Roger. Just a reminder, please do stick around. We'd like to get your feedback on this webinar, but we're going to go ahead and take one more question, which is from Christopher. Are there safeguarding standards that require redundancies for electrical components such as relays?
Yes, even OSHA's regulations go back to the early 70s under control reliability, require redundancy and self-checking of the critical components, and those include relay contacts, those include dual self-checking solenoid air valves. So yeah, that concept goes way back into OSHA and has been updated to the for the ANSI B11 safety standards. It's got a different name to it. I don't think I have it in these materials here. But yes, the concept remains and has been expanded to include the solid state controls that have been the norm for the last 30 years ago. Performance of the safety-related functions is what I'm looking for, is the closest term from the ANSI standard that relates to control reliability. Performance of the safety-related functions is an ANSI standard term.
Okay, thanks, Roger. Well, I do apologize. There were more questions that we couldn't get to, but we will email you back privately later today. So if we could go ahead and cast your vote in our poll to give us some feedback on how you think we did today. so that we can improve for future webinars. Okay, we got about half of you who casted your vote. If you haven't yet voted, please do so. Your feedback is very important to us. Okay. All right. Well, thank you very much for your time and attendance today. We do offer webinars every other month, so check back to see what's on the schedule for April and June and beyond. In addition, feel free to check out Roger's 2.5-day seminars. Both of those are listed on our website on the Education tab. Okay, thank you everybody, and have a great day. Bye-bye.